If you have talked to anybody about their approach to manufacturing, you may have heard them use terms like TOC, Lean, and APS when they discuss their approach. What do these terms mean, and what do they all have in common? Well, let's break it down by discussing each of these terms individually and then showing how they all fit together. TOC stands for Theory of Constraints. TOC is based on the idea that a chain is only as strong as its weakest link. In manufacturing, this means that the throughput of your system can only be as fast as the throughput of the slowest part of that system. Therefore, Theory of Constraints helps organizations identify and focus their continuous improvement efforts on the areas that matter most by using the 5 focusing steps. Identify the constraint, exploit the constraint, subordinate the constraint, elevate the constraint, and rinse and repeat. Lean, or lean manufacturing, asks the question, does this activity add value to my end customer? If not, then that activity is considered wasteful. If so, then that activity is considered not wasteful and is instead value add. A lean manufacturer tries to remove wasteful activities by eliminating the 7 forms of waste. They are transport, inventory, motion, waiting, overproduction, overprocessing, and defects. Finally, APS stands for Advanced Planning and Scheduling. It uses powerful what-if scenarios and considers material requirements, available resources, capabilities, constraints, due dates, desired metrics, and more to help plants optimize production schedules. This makes APS a visual collaboration tool that creates organizational alignment. Now that we have introduced TOC, Lean, and APS, let's use a metaphorical example to show how they all fit together. Suppose there is a facility that pumps red, blue, and green water through a pipe. However, instead of using a typical pipe with uniform diameter, this pipe's diameter changes from one section to the next. In addition, some slime is collected along the walls of the pipe in several sections. As the person in charge of this facility, you are unhappy with the amount of water that is being pumped through this system per hour. How would you go about improving the throughput of this system? First, you use TOC to identify the constraint. In this example, the constraint is the section of the pipe with the smallest radius. Now that you have identified the constraint, you now know where on the pipe to focus your continuous improvement efforts. Now that you are focused on the constraint, you use Lean to exploit the constraint. In this example, the slime deposits at the narrowest part of the pipe are wasteful. Lean is the pipe cleaner that removes this slime. We focus on the constraint because removing slime from the wider areas will not have an impact on overall throughput. After removing the slime from the constraint, you use Advanced Planning and Scheduling to subordinate the constraint. In the pipe example, this means using the entire diameter of the thinnest section of the pipe as much as possible. Therefore, when you have to switch from pumping blue water to pumping red water, Advanced Planning and Scheduling will optimize the schedule and communicate all the steps using its visual collaboration tool to ensure the color change goes smoothly. If you are still not happy with your throughput, you can elevate the constraint by increasing the diameter of the pipe. In the real world, this might mean hiring new workers or buying a new machine. Once this is done, a different section of the pipe may become the system constraint, and you may need to apply lean concepts to that section to remove the slime. You may also want to use Advanced Planning and Scheduling to ensure you have the optimal production schedule given the new structure of the pipe. The pipe example shows that while Theory of Constraints, Lean, and Advanced Planning and Scheduling all do different things, they fit together like puzzle pieces to produce outstanding results.